So, after setting the hypothesis, there are certain things that we need to do after. First, we need to define our statistical test. What is a statistical test? It uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. Now, if you will notice that most of our hypotheses, we write it in terms of null hypothesis. And there are two decisions that we have to make. That is to reject the null hypothesis and to accept. But some statisticians and researchers have issues regarding accepting the null hypothesis. Instead, they say not to reject or failure to reject the null hypothesis. What is the distinction between acceptance and failure to reject? When you say acceptance, it implies the null hypothesis is true, which in most cases is also very difficult to prove. But when you talk about failure to reject, it implies that the data are not sufficiently persuasive for us to prefer the alternative hypothesis over the null hypothesis, which means that we don't have enough evidence to reject the null hypothesis. That's why we said not to reject or failure to reject. Next, we also have a numerical value that we obtain from a statistical test, and we call that the test value. Now, speaking about statistical tests, the t-test and ANOVA, which are found in your data analysis or treatment of the data, is an example or are examples of statistical testing, which we will discuss on a separate video or presentation. Then we also have what we call the p-value. It measures the strength in support of the null hypothesis, and the rule is very simple. If p-value is less than the significance level, we reject the null hypothesis. Now, the test value and p-values are of different methods of hypothesis testing. When you talk about test value, it refers to the traditional way of hypothesis testing. When you talk about the p-value, this is the more modern way, or the p-value method, which is related to the confidence interval method of hypothesis testing. And in our discussion, or in our case, later on as we move along with our data interpretation, we will be using p-value instead of the test value. So, once again, the decision is to reject or not reject our null hypothesis. Now, but take note that in the process of hypothesis testing, in the process of doing our statistical test, there might be errors in that process. There are two types of errors. The first one, we have the type 1 error. This occurs when the researcher rejects a null hypothesis when it is true. The second one is what we call the type 2 error. This happens when the researcher fails to reject a null hypothesis that is false. In tabular form, this is how it looks like. So, the type 1 error, or the probability of committing a type 1 error, is what we call the significance level, or the level of significance. And this is denoted by alpha, or the alpha level of significance. The probability, therefore, of committing a type 2 error is what we call beta, which is simply the opposite of alpha. The beta probability is what we call as well as the power of the test. So, it's just this simple. If your alpha level or level of significance is set at alpha at 5%, it means that your beta level is equal to 95%. And so the power of your statistical test is 95%. The usual alpha levels that we set is 5%, 1%, and 10%. But in our case, we will be using 5%. Now, after we know the statistical test that we will use, after we have set our alpha level, which is 5% in our case, it's now time to make a decision. In traditional way, what we do is we take a look at the critical or rejection region. So it is the range of values that indicates that there is a significant difference and that the null hypothesis should be rejected. We also have the non-critical region or the non-rejection region, which is the range of test values that indicate that the difference is probably due to chance and the null hypothesis should not be rejected. But what value separates the critical region from the non-critical region? We have what we call the critical value. It separates the critical region and the non-critical region. But this process, once again, is of the traditional way. Now, in illustration form, we can see what we call the normal curve or the normal distribution. And in the normal distribution, you can find the region of acceptance or the non-critical region, which is the range of values that if our test statistics falls within, meaning the null hypothesis is not rejected. And if you will notice, it's the majority or the bigger part of our curve. Now, look at the critical region or the rejection region. If our test statistic falls within this region, then our null hypothesis is rejected, which means that we reject our null hypothesis at the alpha level which we have set. So here you can see what we call a two-tailed test. Why? Because our critical regions are on both sides of our normal curve. Other examples of normal curves which has a critical or a significance level of 5% is the one-tailed test, which specifically answers the question, is the sample mean greater than the population mean? And another one is the sample mean less than the population mean? And you can see values below. Look at the first one on top. You have there the z critical value of plus minus 1.96. Now, in traditional way, all you have to do after you have your test value is to compare. If the test value to the right is greater than positive 1.96, then it means that we reject our null hypothesis. In the same way, if it's less than the negative 1.96 on the left, we reject our null hypothesis, because this means that our test statistic would fall on the rejection region. Now, for the one-tailed test, you can see it's plus 1.65. That is what we call the critical value for the one-tailed test at still 5% level. And if our test statistic would fall more than 1.65, then we reject the null hypothesis. Otherwise, we don't reject. Same is true with negative 1.65. If it's less than negative 1.65, then we reject our null hypothesis. So, with this in mind, we go to the steps of hypothesis testing. We have the following. First, we state the hypothesis. We design the study, which include the statistical test, the level of significance, or the critical value, if we talk about the traditional way, population and sampling procedure, and method of data collection. Then we collect the data and we compute for the test value. We evaluate the data using tabulation, statistical test, decision on the hypothesis. When you say decision on the hypothesis, that's when you say we reject or we not reject. And the last is to summarize the result. Now, for the purpose of discussion, let's have a very simple example. Let's take, for example, the one that we have. So state the hypothesis. We have the null hypothesis here. Then we plan and we identify the critical value. So the variables are sex, grade level, and section. Let's, for example, use t-test for independent sample, because we will talk about, or we will try to find first sex. Grade level, we're going to do it using one-way ANOVA. And for section, still t-test for independent samples. So let's try to do the hypothesis testing for the first variable, which we'll use t-test. Here, we will set alpha at 5%. We will determine what testing do we have, two-tailed or one-tailed, but this is two-tailed. The critical value, as you have seen earlier, is negative, or 1.96. The other one is negative 1.96 if it's two-tailed. Supposing you have a test value of 1.98. Now, if you ask me, where did I get the test value? It's from your statistical test to be used, and in this case it's t-test. So after you administer t-test, you have the test value of 1.98. Step 4 is to make the decision. So the decision would likely be, since the test value is greater than the critical value, which means that our test statistics would fall on the rejection region, then we reject the null hypothesis. In step 5, to summarize the result, we say that there is, since we rejected the null hypothesis, therefore we say there is a significant difference in the extent of academic stress of junior high school students when grouped according to sex. Now, if we talk about year level and what's the other one? Section, then we have to do it all over again for another test statistics. Hopefully, this video gave you some sort of